Hello everyone. So in this video we'll cover a lot of things in Java 8 and specifically these topics. You should have a knowledge of collections. So this is a quick and concise video and I have tried to cover almost all topics, primarily major topics for Java 8. We'll first look at lambdas, what they are and why they are needed, since these are the building blocks for Java 8. These are required for usage in the Streams API. Then we'll look at functional interfaces, default methods of interfaces, and some out-of-the-box functional interfaces and their methods. We'll then finally look at the Stream API, the forEach, filter and map operations, optional classes, and some other methods which are not much used, but yeah, these are important. Just keep on watching and I am sure in the end you'll be able to relate what all these are. So if you're new to this channel, consider subscribing, since I'll be posting more of these videos which cover a lot in just one video. So let's start with lambdas. So these are nothing but functions and these are associated with an interface. So what it means is you cannot create a lambda or a function without having an interface. Also, lambdas introduce function programming. So let's say you have an interface and you have an abstract method inside that. You have also have a class and you have implemented that interface as well as implemented that class. So typically you would create an object of this yellow class and assign that to instance variable of that interface and call that function. So that would work. So another way was to create an anonymous inner type and call that via this. So that would also work. So there is a third type which is very concise, small and better, and that is via lambdas. So you would make this function and that you would call it lambda, but it would be a little different in syntax. Also, you don't need to create a class or anonymous inner type for a lambda. So let me copy this hello method and convert that into a lambda. So as I said, lambdas are just methods or functions. So they have some behavior. So they do not have access specifier, so we can remove that. They also don't have any return type, so we can remove that. Also, they don't have any name. I mean, they have name, but not this type of name, so we can remove that. So we are almost done. So after parenthesis, we'll add an arrow. So in Java it would be minus and greater than sign. So this is your lambda or a function. So as I said that lambdas are associated with an interface. Question would arise, where and how would you call them? So this is just a function. So the point is, how would you call that? So since I told you that it is associated with an interface, so its data type would be the interface name. So this is the data type. You can consider like that, and the name of that variable, let's say hello, and like that. So instead of an integer, its data type is, so you can consider it like this and a semicolon at the end. So that's it. Your lambda expression is ready. For calling this lambda expression, you just need to have this instance variable and the name of that. Let me change this name. Now I'll call that using the method name, and the method name of that interface is hello. Let's see if we change the signature of this and the arguments and how would it affect and change our lambdas. So let's say this is a string and this also take a string, let's say name. Of course we need to implement another method, so what we could do is change this. And so let's see if we can use this method and change this into a lambda expression. So first thing, we don't need the access specifier, the return type, So it doesn't matter if it's a void or it's returning anything. You also don't need the name. That's it. And arrow, semicolon, and your lambda is ready almost. So we just need to assign the data type, and that's it. Your lambda is ready. You can test it. So the name of the lambda, and the name of the method. Here you go. So let's understand what I meant by lambdas introduced function programming in Java. So let's say we have created two lambdas. So this is the name of the lambda expression, this is the input argument, and this is the body. So the only difference between those two is that it returns hello and then some name, and this returns hi. So typically what you can do is the first name and the name of the method, the abstract method. Let's say this, and instead of this we write hi lambda. So this would print hello Anuj, and this would print hi Anuj. Okay, so what I meant by functional programming is that from now you can pass these methods as a behavior to another functions. So let's say what you could do is you could pass this behavior or this method or this function to this lambda helper. So let me write the syntax. So this would expect a data type of YOLO. Let's say some lambda expression, and this would call hello. So let's say we can have some string name, and let's print that. So now we can call this and pass this behavior or this function along with some name. So what's happening here is, so you are basically passing this function, whole function here, and this instance variable is now holding this function, and you're executing like that, just as we did here, but now we're doing it in another function. So that what it means. So let's see how we can shorten a lambda expression, which is very important. So let's say you have this interface and you need to make a lambda expression for that, and let's say you make a method like that. So that would contain two arguments. The return type would be string, and let's say this is that method, and this returns let's say sum, like that, sum of a plus b, but in a string format. So let's shorten this up. So no need for access specifier, no need for return type even if it's void or anything, no need for the name, and finally arrow and a semicolon. Finally, to have a left hand side of this, we add the data type sum of a b. So this is it. So let's reduce this. So first of all, we do not need the data types of a and b, since it is explicitly known that this lambda expression will belong to this interface because of this data type, and so we don't need these two data types. So this is fine as well. We can also reduce like that. If we have only one line in the body of lambda expression, we can remove these curly braces also. So that we can put it in one line. Remove the semicolon. Also, if we have only one line in the lambda, we have to remove this return statement. So we'll see how compiler knows about this because of functional interfaces. So functional interfaces are the key for lambda expression. So if you make a lambda expression out of an interface, this interface becomes a functional interface. So functional interface is that interface which doesn't have more than one abstract methods. So let's say if you define another abstract method, let's say void hello 2, you cannot do that. So if you're not using lambda expressions anywhere in your program with that particular interface, you could easily define another abstract method, which is particularly Java 7. You can define n number of methods, but if you want to have lambda expression, you cannot define more than one of an abstract method. So now you must have realized that this is the only reason that compiler knows that what these a and b are. So this is an integer because he knows that there is only one abstract method and I can refer to its signature. I can see what the return type is. So the return type would be some string. Yeah, that's good. And the input arguments are 2, and this looks fine. And first would be int and second would be int as well. So that is the reason. So let's say we return an integer. Let's say we return 3. So that is invalid since this should return a string. So we should only return some string. So let's test this. So the name of lambda expression, sum of this dot the name of the method, whatever input arguments, this would give this result. Let's say you define an interface and this is solely for the purpose of lambda expressions. So you define a lambda expression. So this is how you would define a method. So converting that into a lambda, removing access specifier and name. We do not need the input arguments data type because it already knows that it has to refer this interface, arrow and a semicolon. Of course, this could be anything. It doesn't have to be the same name as this variable. So this could be anything. Now, what if a developer or someone makes some changes in your interface and add some other abstract method? So now what if some other person add some other abstract method inside your interface? So you won't have a compile time error here. Also, that developer also doesn't know that this is solely meant for functional interface. So you might break your code somewhere else in your program. typically in this class which use that lambda expression, or where you have defined that lambda expression. Since it's now confused, it knows that this is a data type for YOLO, this interface, but it doesn't know which method to pick. That is why we only have one function interface. So to avoid this problem, we have that an annotation called functional interface. So let's say you go back to the previous state. So now you have defined that. So by adding this annotation, you have explicitly told everyone that this interface is a functional interface and you cannot add any more abstract methods. So if someone would try to do that, you'll get a compile time error here and then only. So another thing that was introduced in Java 8 was default methods. So let's say this is the interface, and from now on you can define the method, so which is very new. So you can define that. So you can do that just by adding a default keyword in front of that method. So there are two benefits with default methods. So first one is, let's say you have an interface, you have an abstract method, you have a class that implements that abstract method. So let's say there are several other classes along with this particular class that implements this, and you want to have a method in the interface level, but for some of the class, not for all. So if you do, or if you make another method, that would disturb all these other classes. Let's say you have 10 classes and you want in 7 of them this method, so that would not work. So this is one of the reasons. So you can have a default method, and along with that you can have also the definition of that, so like a default implementation. So that would work. So this is some default implementation. So now if you create an object of YOLO class and assign it to an instance variable of YOLO, and if you call that hello, that would call the default implementation. You can also override, of course, and add your own implementation of hello here. So that would work as well. So let's say this is your own implementation. So now you have defined that implementation of your own. Along with that, you are calling the default implementation of that interface method, and now you have defined your code here, and you just call that hello method. So first it will print, or whatever actions you have given in that default method, it will do those actions, and then your own implementation. So of course, if you don't want that, you can just remove this and it will run your own implementation. Suppose you want a function that will take an argument and return something else. So let's first define the lambda expression for that. So now we'll start with our own lambda expression without defining the function in the first place. So in the parenthesis, we need an argument. So it's an int. So let's say this is hello, like h, could be anything. Arrow keys, function body, some color. And since this would return some string, so let's do something like that. So this is ready. So let's assign it a data type, some lambda. So this is ready. So what if you want another function that would return a boolean instead of a string? So you would have to make another interface, and so on. You would have to make another interface if you have some other requirement. So my point is, there are a lot of interfaces in Java that are given out of the box with Java 8. So that is contained in functions package that can solve this problem. So we have a predefined interface called as function particularly, which would resolve this problem. So it can take an argument as an input, let's say anything t, and it would return something like u as a response. So you can search for that by typing this java function docs, and you can go to this Oracle docs. So these are all the functions, or basically the interface. So these are functional interfaces which are given out of the box, which could be used for Lambda expressions. So these are inside the util function method package. So let's go to function. So this is that. So it says that it accepts one argument and produces a result. So let's see this interface. So this interface has some default methods, but it has one abstract method called apply. So this would accept some argument t as an input and return r as an output. So we could use that. So what it means is there is some function which is already present in Java API, have some p as an input argument and return u as an output argument. So let's see if we can use that. So if we replace that with function, so this is that, and the first argument, let's say this is integer, the second argument is string, that would solve a problem. So now our compiler knows that first argument would be the input argument, that means h is an integer, and this string is basically the second argument, the second thing in this function, and this is the return type. So let's test this. So you can do like hello, and then h is some integer variable, and we know the method name inside that function, and we can check that. So this is apply. So this is that abstract method. So apply, let's say 30. So this would return us a string called hello 30. So let's print that. So based on your scenario, you can refer and check whatever fits your requirement for business logic or whatever Lambda expression that you want to create. Similarly, we have different, and these are very important because they would be used in Stream API for each map, reduce. So these are extremely important, but you don't have to cram or like learn by heart for an integer. This is just for reference. So let's start with stream. So let's say you have this list of integer. So what Java introduced was stream. So it got introduced in every collection. So if you do some collection dot stream, so then you can use this method. So what this method would return is a stream class. So stream is basically a class on which you can operate or perform sub functions. So we'll use that. So there are a couple of methods inside this stream. So one is forEach. So this is kind of like a loop, and you can perform some things. So forEach takes in a consumer as a Lambda expression. So consumer has an object as an input. In our case, it's integer, and the return type is void. So it would be something like that, and so this is some kind of Lambda expression for that. So we'll make it here. So inside that, we'll take our integer variable. So let's take it I, it can be anything. So this is arrow function and parenthesis, sorry, curly braces. So that's it. This is your loop. Inside that you can write any business logic, or so let's say we write this out I. So what it will do, it will stream for every object inside that list and it will perform this operation for whole stream. So let's print this. Now let's look at map. So map has in its input argument a function as a lambda expression. So what function is, it's basically an lambda expression which has something as an input and the return type is some other thing. It could be the same thing also, but yeah. So let me give you an example. So let's say you have an integer as an input and the return type is so let's say some string. So this map is used for basically transformation. So let's say you want to transform this list and you want to append some string in front of every element of this list. So what you could do is, so since this is a map, it will take input as this integer. Of course this could be anything, this is just a name, and it would have return something like that, let's see ABC I. Now one thing to note is that this forEach was a termination expression or a termination operation. So this terminates here and there. So what map would return is basically a stream. So this is kind of a chaining operation. So you need some kind of termination. So what I meant is, so if I print list here, so list would be exactly like this. It wouldn't be modified. The only thing that would be modified is the stream here. So since this is a chaining operation, we need to end this. But before that, let's squeeze this lambda expression, since this only contains one line. So we can remove this curly braces and make it in one line, and we can just remove this semicolon. Of course we do not need return because this is the only thing that we are returning, and since this lambda expression returns something, so it already knows. That's it. So let's make this a termination condition or termination operation. So we have a very good method called collect. So this is a terminal operation. So we can collect some into some kind of list. So we use collectors dot to list. Now this collect will return a list, whereas this map was returning a stream. So what we did is, so we're streaming through this list and we're transforming every variable or every input of the stream into something like that. So let's print this list. Here you go. So this is basically a string. So what stream does is, it does not modify the original list, but it transforms, it helps us transform and do various operations with that. So because of this map operation, we are able to transform that into a stream of a string. Now let's look at a filter operation. So let's do stream and then filter. So filter expects a predicate. So predicate is nothing but some lambda expression that takes input as an object and returns a boolean. So let me show you what I meant. So in our case, it will take an integer as an input and it will return some boolean, so like a true or false. So we can have some business logic like something like that, and in the end we would return some true or false. So let's see what filter mean in this context. So we'll have integer and we'll see and check if I is equal to, or let's say it's greater than 3, then we'll return true, otherwise return false. So this is some kind of logic that we can have. So it will stream for every element in the stream and it will check if this particular element, if it's greater than 3, then it will return true. So what's the significance of true and false? So as the name says, filter. So in this output stream, so since this also will deliver a stream, it will have only those elements when it will return a true. If it at any point gets false for that particular element of the stream, it won't be present inside the output stream. So in this case, it will check if this is greater than 3. It's not, it will return false. Therefore, this would be excluded from the stream. Let's first print that. So we can use collect, since this is not a terminal operation. We need something. So dot collect, and then I'm collecting it to a list. So let's have a list. This will again be an integer because we are not transforming it, we're just filtering it. So let's print that, and it will contain only all those elements which are greater than 3. So let's see an example of all these type of operations, which include filter, map, and forEach. So I've taken a model that contains 3 attributes: salary, name, and ID. Here are getter, setters, and constructor. I've created 3 employee objects with the salary, name, and IDs, and I've added that into a list. So let's add toString method inside that. So let's say the requirement is that we have to filter this list on the basis of some name as well as some salary. So we can use stream operation and then we can filter. So let's say the requirement says we have to filter and based on salary. So let's say the salary is greater than 200. Those only employees we need, and those that name starts with A. So since we know in filter we have an input argument, and that argument would be the object which we are streaming upon. So we are streaming upon this employee object. So let's take this as an input argument, and the output would be a boolean value. So this would basically give all salary which are greater than 200. So let's remove all the unnecessary parentheses or curly braces. Since this is the only line, we can remove this, and we can also remove the return. So that's it. So what this will give is all the employees with salary greater than 200. Since for first element of the stream it would return false, so that would be excluded from the stream. Similarly for the second one, but for third and fourth it would return true. So let's say if we have a requirement of getting all the employees whose name starts with let's say A, so we can do again a filter operation. So since this filter will return a stream, so we have a stream of all those filtered items, so we can apply a filter again. So we can apply anything, filter, map, or even a forEach, but that would be a termination operation. We cannot apply any other thing after forEach. So let's say we apply filter. This could be anything. This is just a name that we are supposed to use inside our Lambda method body. So this could be get name dot starts with A. So this would return, so this would first filter on the basis of salary, and then it would filter on the basis of name. So let's say your final termination condition, you add a forEach. So inside a forEach you would have a consumer. So basically what you want is, as an input argument, an object of that stream, so that would be employee, and inside that you can add any business logic. So let's say I'm keeping it very simple, so I just want to print all the names of all those employees. So let's remove this. So we have only Akshay, whose name starts with A and his salary is greater than 200. So let's say you want to transform that as well, and you want to transform this into some kind of other thing. So you could use a map after this. So at this point you have only one object, this one. So let's say you want to transform this employee object E into some kind of a string. That also you can do, but that doesn't make sense, but you can do. So since a map contains a function, so it contains an input argument, so that would be a object, and you can transform that into, so let's say you want to transform that into the name of that the name of that person. So that's it, you've done that. So at this point your stream has been reduced from an employee object to basically a string. So the stream now contains only one element, and that is Akshay. And for just proof we can just print that for each. So this is just one, you can just use that's it. What you could also do is you can use collect, and you can add collectors.toList, and you can collect all the list of new employees. Since this list has now been transformed into some string, so that would be string. Let's print that. Here you go. So let's say you have a list that contains list of integer. So that means this is a list, and inside that you have one sublist. So this is that first sublist, and this is the second sublist. So let's see in print what this is. So this is one list, and inside that we have few sublists. So this is that 0th index, and this is the first index. So let's say this is that output of this list, and what we want is we want a list that could contain only those elements which are in this list plus in that list, basically which are in every sublists, and we combine that into one simple list. So for that we can use a flatMap. So let's see how we can do that. So we can use stream method. So this stream method would return a list of integer. Now on that we can use a flatMap. So for Lambda expression for flatMap, so what it expects is the stream's object. So the object of stream is list of integer. So this L is a list, and the return type would be a stream. So let's say this is that. So you can check what it returns. So let me show you. So that is some integer. So you have converted a list of integer to integer. So this was basically an input of stream of list of integer, and now it's a stream of integer. So you have gone basically one level down. So flatMap returns a stream, so we can collect that into a list. So a terminal operation, collectors or to list. So let's have list of integer, new list, and let's print that new list. So you can see we have gone down one level, and that's basically the most versatile or the most useful feature of flatMap. So it could be anything. So now this is an integer array. So this is basically a list of integer arrays. So this is the first item of that list, and this is one integer array, and this is the second. So this could be anything. So this could be a list of integer, or list of, or inside that it could be also a set of. So that could be anything, any data type. So let's write our code. So we have done the stream operation on this list. So this would return the stream of integer array. On this we can do a flatMap. So the input argument of flatMap's Lambda expression is the stream that we are performing on. So this is some kind of integer array. So let's write down integer array, and the return type is basically a stream. So we can do arrays dot stream. So for giving a stream of an array, you should try to use this inbuilt method of arrays, which can take an array of integer. So int array, and we could return that. So now this flatMap will return a stream of integer, and that we can capture inside collect method, collectors dot toList. So here we have captured that list. Here you go. So this data type could be anything. It could be an array, list, set, or anything else. So let's look at optional. So this is basically a class which wraps some or the other object. So here it's wrapping around this string called Anuj. So you can think of it like a wrapper or a container which can wrap any object. So currently it's wrapping this, and it's doing with the help of this method of. So this would return some optional of Anuj. So you can store that inside an instance variable of type string, since this is of string. Now there are a couple of methods that we can use with this. So let's say name is present or is empty. So this is part of Java 11. So is empty was introduced then. Is present is part of Java 8. So what it tells is, if something is present inside this that is currently present, we have to return true, otherwise false. Opposite is for is empty. That is, if nothing is present inside that optional container, then it will return true. So let's see. So since name is present, it will return true. So one thing, if this name is present like that, name of person, let's say, and we assign this name to this, so that would work fine. But if somehow this string, which is an object, is initialized to null, or if it's null, then this would give an error, and that would be a runtime error. So this optional.off cannot handle this, and it will give a null pointer exception. So to handle this, you can use off nullable. That is another one. So it could handle those null values. So since nothing is present in this optional container, name, that is why is present is giving false. Similarly, is empty would return true. But this is part of Java 11. So we have if present. So this expects a consumer as a Lambda expression. So we already know that a consumer is something that expects an input argument, same as whatever we are streaming. So here in case we are having a string, and in return it would be nothing, just void. So you can have your own business logic here. So you can write anything. So let's keep it simple and write. That's it. So we're just printing whatever we have inside that. So here you go. So let's look at if present or else. So we have this method. So this would accept two arguments. One is a consumer and another is runnable. So this is the first thing. So if something is present inside this optional box, we will do some action here. So this is a consumer, and for this, if you want to make a Lambda expression, we can use this method, and that would accept some argument, and its return type would be void. So this is similar to a forEach. So forEach also accepts a Lambda which has some argument. So we are streaming upon some string, so that is the same thing, and you can write this your own business logic here. So we can write something like, so because of this it's not working. So this is S, and in the second argument we have a runnable. So we know runnable is something that accepts nothing, and its return type is also void. So it accepts nothing and the return type is void. So you can add your own business logic here. So we can write name is present and name is not present. So I've already set the name to null, so this, there would be nothing inside optional box, and this would execute to this second action. Name is not present, and if we write some name, and then this would be executed. So let's quickly clear this up. Since this is only one thing in our lambda expression, we can remove this curly braces. So this looks very neat. So let's see how we can work with reduce. So this is part of streams. So let's say you have a list of integer elements. So you do a stream and then a reduce. So it expects a binary operator as a lambda expression. So what it is, so it's basically two input args, A and B, and those are basically the data type that you're streaming on. So we are streaming on integer, so that's what it is, and the return type of that lambda expression is an integer. So let's say we do a plus b. So what it does is it basically reduces this whole stream to a sum of all these elements. So first let's print this. So this type of reduce is basically giving us an optional. So let's see how we can get this. So you do a dot get to get an optional and it will return an integer. So first let's print this integer. So this is the sum of our stream that we had. So let's see how reduce works. So for that I will just expand this and add some curly braces, and here I will add return. Basically I'm expanding our lambda expression, and before that I'll just add sysout AB. So for each element of stream it will give us A and B, and we'll get to know how it works. So let's comment this. So here A is 1 and B is 2. Then the result A plus B, which is 3, gets A in the next stream element. So then A is 3 and B is 3, and the sum A plus B is 6. Then 6 becomes A and the next stream element becomes B. So one thing to note here is the reduce expects a binary operator as a lambda expression. I mean the type of lambda expression is of binary operator, so we can refer to that. So just need to go to Java function docs and search for binary operator. So here it is. So the type of function that we're using is this one. So it has two arguments as an input and third as an output. I mean the return type. So one thing to note is the first, second and third, that is the input A and B as well as the return type, should all be the same data type. So what that means is, let us go back. The input A is an integer, B is also an integer, and the output returning of A plus B should also be an integer. Then only it will be running compile free. So if I do and return a string or something like that, ABC, so it won't work. So apart from this, we have another type of reduce, so that expects an integer in advance. So let's say we add 10 and we have the same expression, that lambda expression A comma B, two input args, and the return type is some integer. So what this does is, first of all, it will return directly an integer. So let's see this method. So this is an overloaded method that returns something of type t. So here t is our something that we are streaming upon. So here in our case it's an integer. So this is same. So only thing in the difference is is this 10 or some integer element in this case. So what it is here, A becomes 10 and B becomes 1. So instead of picking two elements from the stream, it picks one element and the rest is same. So let's see. So this will give all this sum plus 10. So let's see how it works. So here you go. 10 is the first element A and B is 1. Sum is 11 and that becomes A. So 2 is second stream element. And this is how it goes. So it gives the sum as 20, that is all of this plus the initial. So let's look at some of the other methods of stream. So let's say this is a stream of integer. So we can check that stream of integer. So the one method that we have is count, which would give the count of all this stream objects that you have inside the stream. So this gives a long. So let's print this. So that's it. So another method which we can look into is this anyMatch. So this anyMatch accepts a predicate. So predicate is a interface which could contain a lambda expression that accepts an argument of t and it would return a boolean value. So something like that. So anyMatch. So since we are streaming on integer, we'll have an integer, let's say I, and we want is some odd number. So we could do something like that. So we are returning if that particular number mod 2 is not equal to 0, that is if it's an odd number, then that would match. So here it would match since this itself is an odd out of these, so it would return true. So let's print that. So let's remove all the odd numbers. Since it cannot find any match, so this would return false. So we have a few other methods. This is findAny. So it will return an optional of any of the objects of our stream. So we can get it by doing a get and it will return an integer. So this is what it gives. So typically it would give the first element. We also have findFirst, so which is similar to that. It also gives an optional, and this gives a first element. So the only difference between findAny and findFirst is it doesn't usually give, but sometimes it gives the first element. So it's also given in the documentation that this is non-deterministic, so it could not give the first element. So let's see. So it's saying it's free to select any element in the stream. So we have a map here that has some values. So apart from doing the usual key set and value set operations that Java had already had, so we are having another forEach. So this time it's not a consumer, it's a by consumer. So this forEach will accept two arguments and the return type would be nothing, void. So you can write any business logic. So it represents an operation that accepts two input argument and returns no result. So this is that method. So let's see how we can use that. So we'll have two arguments. So we typically write it with kv. You can give it anything. So this tells that it's a key value pair, and you can write your own business logic here. So let's just print key value here. Let's say you have a list and you want to apply some filters, map, some operations anything, and then you want to convert that into a set or something like that. So you can have collect method, and inside that you can have collectors dot. So now instead of using toList, I'm just using toSet. So this would obviously give us a set. So that would be a set of whatever we have in that stream at that particular moment. So let's say we have doing a map and we are converting these integers into some string. Let's say the input is this I, and we want to convert that into a stream of string with starting with hi. So this would become hi1, hi2, and so on. And finally we are collecting that. So let's print that. So this is a set of string. Let's say you have a list, and now let's use the property of collectors.toMap to convert something of a list and to a map. So stream collect. Now instead of using collectors.toList or toSet, we can use toMap. So this would accept two functions, two lambdas which belongs to functions. So one is for key and another is for value. So this first lambda function, so this is part of a function. So function is something that accepts one argument and produces a result. So this is very similar to a map, which is used for transformation. So now this input argument would be something that we are streaming upon. So we are streaming upon integer, that is these elements, and the return type would be whatever you want. So let's say we want to make key of our hash map as integer, these only, so return this only. In the value we'll have the same integer. Let's say you want to write something like hi and I. So this is something that you want. So this value would be hi1, hi2, hi3, and so on. So this map has now become something like that. The key here has become integer and the value has become string. So that depends all upon you. So you can have a business logic by writing some curly braces and then you can write some code here, but it should return some value since it's a function. So map is of type integer as key and string as value, and we can print this. So here you go. So this is one of the most important points to remember if you're using collectors.toMap. So let's say you have introduced one more element and you are streaming over this list. So this would generate a null pointer exception because we have duplicate keys. So this is what the exception would look like, illegal state exception. So it's saying duplicate key, so that is what it is. So what's happening here is we need to tell this collect method that what value we need to pick from either of these keys. So we know in map the keys are unique, so we don't have repeating keys. So obviously the key will be 1 in this case, but it doesn't know like which value it needs to pick, either from this one or this one, since both have the same keys. In our case, in this example, it's not a good example, so we will have the value as hi1 in both the scenarios. So let's look at another example, but before that we need to see how we can fix that. So this type of collectors.to method accepts two arguments. We also have an overloaded method that accepts a merge function. So this merge function is of type binary operator. So a binary operator is something like that. So it represents an operation that accepts two operands which is of the same type, and it gives a result which should also be of the same type. So like that, two input arguments of the same type and output would also be the same. In our case, so this was one overloaded method of collectors.toMap, the other that accepts a merge function. So let's write that. So it accepts two argument. So let's say this is the first argument first, this is the second argument second. So we need to return an element which should also be of the same type. So let's say we return this. So let's see what these are. So these are basically values. So you can see the data type, it's string. This will also be a string, and this will also be a string. Since our map is expecting value as a string in values, so this is the first value of the first key, and this is the second value of the second key. So unfortunately in our case it's same high one, and for this key also it's high one. So you basically have a choice whether to return value from this key or from this key. In real world scenario, you would have a business logic like that. You would have some curly braces, and inside that you can write business logic, and based on that you would finally return some value. So let's see that example also. But first let's run that, and it's working fine. So let's see this example. So we have a class called employee. So this is a model which has two attributes, ID and name, some getter setters and constructor. So we have created 3 employees and we have added that into a list. So this might not be a very good real case scenario for that, but it's really better than the previous example, and this should explain why, and this should tell you what not to do when using collectors.toMap. So let's write the code. So we have employees stream, and then we have collect. We do collectors.toMap. But before we write a key value pair and our mapper functions, what we can do is, let me tell you what I want in the output. So I want to convert this list into a map. So the map would be ID should be the key and name should be the value. So ID is int, so we should have integer as a key and string as value. So let's write down our toMap function. So the first argument is for key, so this would be get ID, and the second argument for getting the name. So that's it, you've converted that into a map. So our map will now look something like that. So it will have ID as key, so ID is basically an integer, and name as value, so name is string. So this is our input arguments for our toMap function. So let's print that. So as you can see, this is our key 450, and the value is the name of that ID. So this is employee ID and this is employee name. So now what if your employee ID is same? So this brings back to our previous question. So now it doesn't know which value to put in place of 120. So it knows that this would be same, that this could be key or this could be key. So since key is unique in hash map, so it doesn't matter that, but what matters is which value to pick. So it doesn't know that, so it should be first or second. So that is why we need to add a mapper function. So we already had an overloaded function for that. So in toMap, so there are different kinds of toMap function, so we need to use this. So let's write the third argument, which accepts two arguments in the lambda. So one is the first, second. So this is a string. Why do we know this is a string? So since our value lambda is returning a string, so that is why it is a string. So it basically matches our value. So whatever data type the value has, in this case it's a string, so then it's a string. Then this would return something. So let's say our business logic says that we should always have the second name as the candidate for the value. So it doesn't matter what should be the ID, but the name should be second, that is iterating or streaming upon the stream that we have. This would be the output of that. So it would reject this key, this value, and it would take this value since we are giving it a second. So let's print that. So here you go. So we don't have that. So let me show you by removing this, and we'll get an illegal state exception. So here you go. So this is for duplicate key 120. So since we have duplicate key, and for these two values. So this is a small workaround for that, and this you should keep in mind while using collectors.toMap. So there are a lot of things to learn in Java 8 in particular, and this is what I could squeeze in one video. If you liked it, just subscribe to this channel. Of course, if you have come this far, just hit that red button. Thanks for watching. Bye.